in Chapter 4, Learning Target 11, the end of Chapter 4, the end of Chapter 4. This is Miss Oshier.
And Miss LaHart.
And here we go.
It's just felt like we were never going to get out of here, but we are.
We're here, people. It's the end.
All right, the last thing we have to talk about is inverses.
Not reciprocals.
Not reciprocals. Inverses. Remember back to inverses where you switch your x and your y. Well, in this situation, when we go to switch the x and the y, like our normal x represents an angle measurement, our y value x represents a measurement that pops out. Okay. So when we do the inverse,
we still have the measurement and we still have the angle. So the purpose of the inverse is to find the angle.
Yep. Okay. I don't know what's popping up. To represent inverses with trig functions.
So to do this, you're either going to say it's sine to the -1, or you're going to call it, it's called arc sine, or arc cosine, arc tangent. It's just fancy words.
For the inverse. And you're more used to the one with the -1.
Yes. So
when your calculator, that's what that one uses.
This is the inverse of sine. Arc sine is also the inverse of sine. Okay. But again, x becomes the measurement, y becomes the angle measurement. So inverse functions are 1 to 1. Thus, their graphs must pass the horizontal line test. Now, if you just quickly imagine your sine wave or your cosine wave in your brain, they do not pass. Do you notice how my voice gets?
She was closing her eyes. That's why I'm giggling.
If you visualize them, they don't pass the horizontal line test.
Not at all. They fail it.
Nope.
Look at that thing. Fail. Fail.
In case you couldn't visualize it.
Failing.
Ooh, tangent.
Fails all over the place. Okay? So the domain must be restricted when we talk about the graphs of the inverse functions.
So, we just talked about it for a little bit.
Yep.
So here's the graph of the inverse of sine. It goes from negative pi over 2 to pi over 2.
Because you think about like where your sine curve ends. We have to cut it off at places when it starts to go back in the curve. So remember, because it's the inverse, on your y-axis, you're actually going to have degree measurements, and then your x-axis is actually going to be units. So that's another thing that's switched around.
So our units are -1 to 1. Unit circle, right, people?
Yep.
And our range is negative pi over 2 to pi over 2.
Yep. And again, we're just switching the x and y values for that sine curve. And
we're basically just choosing this box, because this box passes the horizontal line test.
Yep. Cosine is, again, we have to restrict it. If you, there we go. So in order for this one, we actually restrict it over the values of 0 to pi.
Boom.
Okay. Oh, yeah.
So from 0 to pi, that swoop down almost, that passes the horizontal line test.
Yep. Tangent's the funky one, which domain is no issue, because when you reflect this over the line y equals x, you got a line that snakes all the way to the right and all the way to the left, so domain is not an issue. But range, again, it will be from negative pi over 2 to pi over 2, because you want that one section.
Yep. So right here.
So basically, the only thing that you'll have to be able to do is if we show you a graph, you can tell us whether it's the inverse of tan, inverse of sine, inverse of cosine.
So if you were nervous, don't be as nervous, because you're just picking. You're saying that one is the inverse of tangent, that one is the inverse of sine, that one is the inverse of cosine. So here's a quick summary. If I were a student, I just heard what we just said, I might make a little sketch next to this summary to be like, this is what I'm responsible for, so I should make a sketch of this. Just saying.
All right, so we're going to play with the inverses for just a little while longer. Okay, what does this actually mean? When I have the inverse of sine to the -1/2, it's asking you what angle measurement gives you a -1/2 sine value.
So if we think sine is the y, where is y 1/2? So if you look at your unit circle or you do your hand trick, that's going to be at the 30-degree angles and all of their reference angles.
But we need it to be negative.
So we need to be in the 3rd and 4th quadrant. So there are actually 2 solutions.
Well, we restricted over the domain, so that's why you only get one.
Yep, that's right. I'm sorry. We're going off of the restricted domain. But in later chapters, we're going to unrestrict that domain.
So cosine is the x value. So where is the x value? 0. It would be pi over 2, because remember, again, we restrict the range from 0 to pi.
0 to pi. Tangent is y over x, so where is that value? Negative radical 3. It's at the 60-degree angles. Oh, yeah. That's why I like knowing tangent, because I don't have to do all that. But for those of you who, that's what you got to do, people. Okay?
And I mean, you can plug this into your calculator, and it's going to pop out. If you're in degree, it's going to pop out 30.
Yep.
or negative, excuse me, negative 60. But you would have to switch it to radian measure
Yes.
if you're scared.
But yeah, your calculator will do this, and we're not taking it away from you.
Nope. This is, again, it's just kind of like, do you know how to work your calculator, I guess? Do you know what it's meaning? So,
and also, do you understand what an inverse is? Because if I do the sine of the inverse of sine, inverses and original functions undo one another.
Mm-hmm. So where is it a half? 30 degrees. Sine of 30 degrees is a half. So they undo each other. So ready? What is this one? 1.8.
Boom. That's just a quick reminder. Those are like little like, oh, you might be overthinking it, but it's just boom.
Yep.
Those kinds of questions.
Way to have my graphics up.
Ooh,
all right. So
all right. This one definitely got to do more.
Yep.
So the inverse. So what angle is the opposite 12 and the hypotenuse 13?
Yep. So if I put my angle there, opposite hypotenuse, use Pythagorean theorem, I get 5. Okay.
Ooh.
So then going back to it, so once you've figured out your triangle for the sine, value, then look at what's the cotangent of that triangle.
That would be A over O,
Yep.
so 5 over 12.
Mm-hmm.
For something like this, you would have to have the knowledge because we would say exact value.
Yep.
You couldn't just second sign this.
So just set up your triangle. Sine is opposite over hypotenuse. Put those values where they need to go, and then figure out what the cotangent of that same angle is.
Mm-hmm.
Do I do another one? Oh.
So here's another one. So tangent of pi over 4. Pi over 4 is a 45-degree angle, so I know that my tangent is 1.
Okay. So once that goes in, hopefully I did this in pieces. But look at that.
What angle is sine 1? Well, if I visualize making a circle, or I just look over here, sine is 1, y is 1 at 90, which is pi over 2.
Mm-hmm.
And technically, we probably should have put pi over 2 here.
Yep. Whoopsie.
Because we gave it to you in radians, so we would expect it in radians.
That's it.
That's it. So have a great day. We'll see you in class, and yay for the end of chapter 4.
Woo!